Prior to the 1960s, there was no knowledge of plate boundaries and their impact. It wasn't until post-World War II that a widespread use of seismometers to track nuclear testing displayed a pattern of earthquakes and volcanoes along belts around the world. This mapping of geological processes was later found to be the mapping of tectonic boundaries. As can be seen along places such as California and the Ring of Fire, the seismic activity displays an obvious belt and correlation which describes the line of the plate boundary. This led to the discovery that oceanic trenches and basins are formed along these belts due to the convergent, divergent, and transformal interactions between these boundaries.
You may be wondering, how exactly are these huge chunks of land and ocean moving across the Earth? Well, it's not so simple. At a basic level, we first have to understand a little bit about the Earth's interior. There's the metallic core, the thick mantle, and finally, the very thin crust which we all live on. It's this very upper section of mantle and the crust that make up what we call the lithosphere. This is the first solid section of Earth that is ever so slightly moving. The driving force behind this process is the internal heat that is released from elements deep within the Earth. The energy is carried through a process of mantle convection, where the mass movement of material beneath the Earth's surface is accounted by this source of heat. Heat flow operates differently underneath continents compared to oceans, and this is due to the difference in crust thickness. Oceanic crust is much thinner, denser, and is influenced a lot more by heat flow, so these plates move much faster. Continental crust is thicker and consists of large amounts of heat-producing elements that affect its movement. Over the billions of years, the Earth has seen a lot of tectonic movement from these forces, and here's what it looks like today. You'll notice some of the major tectonic plates, including Africa, Eurasia, North America, South America, Australia, India, and the humongous Pacific plate. The other smaller plates are also shown, but my personal favourite is this little guy, the sandwich plate.
There are three primary types of plate boundaries: convergent, divergent, and transform boundaries. In the case of divergent, these plates move in the opposite direction, away from each other. Magma rises from the surface and fills the gaps created, forming new crust. It is for this reason divergent boundaries are known as constructive boundaries. The Mid-Atlantic Ridge is a mid-ocean ridge formed this way. Convergent boundaries involve two plates colliding with one another. Continental plates uplifted the Himalayas over the course of millions of years. In oceanic plates, one will subduct under the other, creating a trench and causing magma and volcanic arcs to surface, as is the case in Japan. This leads to all kinds of weird and wonderful variation in biota and the environment, like this little guy, the fanfin sea devil. He lives in the deepest point of the Earth, in the Mariana Trench, on a convergent boundary. Transform boundaries are conservative. Crust is neither created nor destroyed. They simply mesh in an opposite direction to each other, in the same motion as rubbing your hands together. The San Andreas Fault is a beautiful example of a transform boundary. Australia lies in the middle of a plate, far from many boundaries and hence doesn't experience many natural disasters. Movement of the plates is the main cause for disasters all over the world, including eruptions, floods, landslides, and tsunamis. Predicting these disasters before they occur is very difficult and expensive, so it is important to understand the Earth we are living on if we want to save lives.
Tectonic plate movement affects humans. Earthquakes and volcanoes appear mostly along the plate boundaries. These impacts are positive and negative. Positive impacts of earthquakes include the emergence of sand dunes or beaches and new plant life. Positive impacts of volcanoes include providing nutrients to the surrounding soil and minerals from the ash. Humans live near volcanoes for this fertile soil. Negative impacts connected to earthquakes and volcanoes include gas release, pyroclastic flows, fires, building collapse, lava, ash, and tsunamis. Shallow earthquakes over a 2.5 magnitude are human-felt, recorded up to 9.5. Volcanoes occur between a volcanic eruption index of 1 and 8. The Ring of Fire circling the Pacific Plate hosts 90% of the global annual earthquakes and 75% of its volcanoes.